Hello, I'm Dr. James Giordano, professor in the departments of neurology and biochemistry, and chief of the Neuroethics Studies program at the Pellegrino Center for Clinical Bioethics here at Georgetown University Medical Center. Our ongoing work in the center has focused on those ways that neuroscience and technology, somewhat colloquially referred to as neuro-S&T, engages a whole host, a variety of different applications across the spectrum, from not only what's viable in medicine, but ever more what's become part of public life. Our capabilities in neurosciences in many ways are being seen as bold, literally bold, going bravely sometimes where we haven't gone before. But the question is, do we have an ethical system that's able to deal with the arising issues, questions, and problems as neuroscience becomes ever more not only tenable, but part of the trajectory and realizable on the 21st century world stage? Indeed, neuroscience and technology, neuro-S&T, puts the brain at our fingertips, literally puts the brain at our fingertips, very often in increasingly non-invasive ways, allows us to look into the brain, to map the brain, to study the brain, to understand the brain further, not so much as an enigma or a mystery, but more as a puzzle to be solved. And this really underscores the fact that there's an ongoing dance, if you will, a tango, where both may lead simultaneously in an organized and orchestrated way of tools of observation, engagement and manipulation, and theories. And we come to the limits of those theories, and very often that prompts the development of ever more capable and sophisticated tools. In putting the brain at our fingertips, what it really allows us to do is to put our fingertips, and if you will, our futures, into brain science. So what we're able to do with neuroscience and technology at this point in time is to maximize our capability according to what's known as the 3 A's of engagement. We can assess the brain with plans to map connectivities in the brain, to understand structure and function relationships. But once we understand those structure and function relationships, we try to access the brain on a variety of levels, from the cellular all the way to the social, from the individual all the way to the international. And in so doing, we affect the brain. Assess, access, and affect. So what are these emerging tools of the brain sciences that allow us to not only expand our theoretical understanding of how the brain is structured and functioned, but perhaps also our realistic capability to engage that brain, to affect that brain, and to be less politically correct, perhaps to manipulate that brain? Well, in the assessment technologies, we have such cutting-edge devices and tools such as biomarkers, genetics, and genomics to be able to map the genomes and individual genetics that constitute the structure and function of our nervous system, and in those ways maybe contribute to our thoughts, our emotions, behaviors, who we are. The neurogenetics of identity, if you will. Brain imaging that allows us to view the living brain in relatively real time. And of course, this allows us to not only model the brain, but to map the brain, very much the same way that cartographers of old mapped those ever-expanding boundaries of what was known and what was not known of the ecologies and world in which we live. We're mapping the ecologies and that world, that universe within, that is the brain-mind. But in mapping the brain and identifying these structures and these functions, we develop capabilities to access them, essentially to target them. And here we see the interventional neuroscientific and technological tools. Variety of technologically based pharmaceutics that allow us to utilize nanomaterials to access the brain in ways that heretofore were unimaginable and impossible. Peripheral stimulation, central stimulation, neurofeedback, transcranial modulation that goes through the skull but is non-invasive, and then ever more invasive forms of deep brain stimulation. But we're taking that one step further to minimize the level of invasiveness, to be able to implant things into the brain with only minimal or non-invasive techniques and technologies. And we're yoking the brain ever more to computational interfaces and building from that neuroprosthetics and neuroorthotics that allow us to essentially rebuild a broken brain. But none of these are capabilized or possible without some of the derivative tools and techniques that brain science brings to the fore, brings to its workbench. These include things like artificial neural networks that can be modeled and then put into computers, And then the reciprocity of those computational systems with the brain to develop AI, artificially intelligent technologies that are indeed reciprocal and cooperative. What we see the brain science is doing, like so many other fields, but perhaps best leading, if you will, the field, is engaging this new paradigm of integrative scientific convergence, ISC. It brings together the natural sciences, biotechnology, anthropological and social sciences, and the humanities. Why? Because neurosciences, like so many of the sciences, aims, seeks, orients to address, if not answer, the predorable questions of human anthropology, of human sociology, of our thought, of our philosophy. And what this allows us to do is to gain insights to what it is we are. The mathematician and philosopher René Descartes posited, "I think, therefore I am." The flip side of that coin, if you will, is really, how do I think? And if I can understand how I think, what does that tell me about not only who I am, but does that then allow me tools, perhaps, to modify, modulate, direct, self-engineer who that who is? And what this allows us to do is it gives us the toolkit to be able to both assess and affect individuals and groups. And one of the key drivers of that is being able to assimilate, synthesize, and utilize in real and rapid time huge amounts of data. The tools of big data integrated with the tools of artificial intelligence have capabilized the brain sciences to a set of abilities, to a frontier of both probabilities and possibilities that just 10 to 15 years ago was almost unimaginable. Indeed, what we find now is that neuroscience fiction, nonfiction is becoming realized. Things that in the past seemed to only be the stuff of science fiction is now at our fingertips, is now a realistic both probability and ever more emerging possibilities as these techniques evolve and as those who use them understand that by bringing them together, we can open up a vista of things that we can do to assess and access and affect the brain. These include the use of gene editing techniques, probably most notable today, the use of CRISPR, Cas9 gene editing, gene scissoring techniques to be able to modify the genetics and genomics that contribute to the way our brain is structured and the way our brain functions. On the assessment side, more and more we're being able to utilize forms of neuroimaging to literally reconstruct the input to the brain that that individual was experiencing. In other words, as we see here in this slide, you can image my brain and from that image relatively reconstruct what I was seeing, what I was hearing, what I was feeling. And of course, we can put all of these together into new areas that allow the integration of assessment and intervention. Probably most notable among these has been some of the programs coming from the Brain Initiative, spearheaded here in the United States by the Defense Advanced Research Project Agency, DARPA. And probably the most exciting and cutting edge is one called N3, Next Generation Non-Invasive Neuromodulation. The capability to put vast arrays of sensing and transmitting electrodes deep within the brain in a non-invasive or minimally invasive way to allow real-time access to read from the living brain and right into the living brain remotely, through the cloud, through the web, via distance, across time. And then if we push the envelope a bit further, we begin to see the merger of those ideas that heretofore were thought as, well, perhaps impossible, but now made possible through the conjoinment of a variety of different neurosurgical, biological, biochemical, genetic techniques. Probably most avant-gardistic of that is some of the work of the neurosurgeon Sergio Canavero, the Italian neurosurgeon, who, building upon some of the prior work of Dr. Robert White, is attempting to complete the first human body-to-head transplant. Now, garish as that might sound, the motive is in fact benevolent. I had the opportunity to speak with Dr. Canavero on multiple occasions, and the low-hanging fruit here is the capability to essentially do good. Yeah, what do we mean by doing good? Well, individuals whose bodies are ravaged by neurodegenerative diseases or other forms of diseases, but whose brain, whose mind is intact. Could we not perhaps facilitate a better quality of life? I mean, realistically, we can say that if someone donates their body to science as an organ donor, might we not use the body in its entirety? And of course, there are technical difficulties and there are huge hurdles. But building upon some of the prior work, the point we're at right now is, well, we could probably get some level of survivability, but now the question is to improve the quality of that survivability. And Canavero argues we won't know what that experience for the individual with a transplanted body is like until we go there. And yes, there are those who push back strongly on the ethical front and say, oh, it's dripping with the yuck factor. But there's plenty of things in medicine that are dripping with the yuck factor. And more than that, this is done with consent. And this is not a small queue of individuals who want to be, if you will, the first neuronaut to boldly go, literally boldly go, where no one has gone before. This may even be seen as a learning exercise. What is it like to have a new body? What is the essence of self? What is the identity that comes as a consequence of that? A bodily set of experiences that are now being processed by a brain. But this isn't fiction. This isn't just some rhetorical exercise. These are things that are actually possible in today's world of neuroscience. The domains of application certainly include medicine, as we see, neurology, neurosurgery, psychiatry, rehabilitation, pain medicine. Paraclinical domains as well, occupational issues and preventive medicine, working essentially before something goes wrong on healthy people to keep them healthy, occupationally protected, and enabled. And now some may say this opens the door, or the proverbial Pandora's box, for discussions of what constitutes treatment or enhancement. But so much of what is preventive is focused upon keeping individuals off the slope, slippery or otherwise, of being made vulnerable to injury, disease, or simply the frailties of human existence. We have to ask then, how far do we go? How far should we go? And if we're asking how far we should go, please understand that throughout human history, virtually any of the emerging tools and techniques that we have used have been put to work for agendas and initiatives of national security and defense. And brain science is no different. The interest in the brain sciences has certainly been manifest for decades, but has really increased with regard to the possibility of utilizing brain science in dual usable ways for warfare, intelligence, national security. And of course, that's an international agenda. Here, too, we have to appreciate that the goal is, quote, good. But who's good? But justice, what rationale, to paraphrase the words of Alistair McIntyre, the philosopher at the University of Notre Dame. Militaries defend the polis, at least in an open society. And so should we, can we, will we use brain science for those orientations, those means, those initiatives, and our desires to keep our societies protected? But what of other societies? What of different values? What of different ideologies? How will brain sciences be used there, and is there an absolute good? But let's back up. If we're talking about doing good for the polis and protecting those societies, what about the societies use themselves of the brain sciences? And ever more what we see that indeed what's happening is the brain sciences are becoming part of public life. Using the brain sciences in direct-to-consumer and even do-it-yourself means for educational purposes, for wellness purposes, and for lifestyle purposes. Well, indeed, what we see is that neuroscience and technology offers not only the probability to push the envelope of what we can do to be able to assess and access and affect the human brain and its functions, which we'll colloquially refer to as mind, which in many ways are the seat of the self. The potential is there to harness these things in a variety of ways, to be able to affect human relations on local, regional, and global scales, affect human thought, emotion, behavior. And of course, when we're able to do that, then the influential process and posture increases dramatically. There's great power there. But there's more that we need to understand, not just in the power of the neurosciences, but in the diversity of neuroscientific initiatives and agendas on the world stage. Current predictions and estimations are such that China will be on pace to essentially outspend and outpace the United States, if not the West, in quotes, what was formerly referred to as the West, within the next 10 years, by intent. By intent. With almost a 70% increase in research, development, test, and evaluation in the next 5 years, and a predicted 50% plus gain in overall market share in the neuroscience and neurotechnology fields within the next 10 years. But clearly, it's not simply China on the global stage. Russia has profound programs in the brain sciences. Evermore, we're seeing the use of virtual currencies and virtual nations that are engaging the brain sciences, or at least utilizing its tools. And as we said earlier, even do-it-yourself initiatives and agendas, which for the most part are certainly ethically probitious. But here too, the possibility for corruption, the possibility for capriciousness, if not nefarious, within those communities raises its head and requires at least some look-see, if not some regulation and guidance. But the take-home message here is simple. Neuroscience and technology are not simply the Provence any longer of what used to be referred to as the West. It's a global enterprise, primarily among developed countries, which then raises the specter of what are those ethical issues, focal ideas, problems, and questions, as brain science in developed countries is utilized globally. How will it affect developing or undeveloped countries and their peoples? How will different developed countries' ideologies, ethos, ethics, morals, and laws affect the way brain science is studied, articulated, and used in a variety of its domains of application? We can view this, if you will, as more congenially as the good, the bad, and the ugly. But each and all of these might be relative terms. Who's good? How do we define good? How do others define good? You clearly, once again, I think the benevolent motive here is to be able to treat disease and injury, to lessen the human predicament and improve the human condition. But like any other tool, it's reliant upon those who develop the tools and use them. And in some cases, there's misappropriation of the findings of brain science, the tools of brain science. And of course, who gets the goodies? And what does that then mean for the distributional asymmetries that occur within countries and between countries? And if we look to what some might consider to be the dark side, and perhaps verifiably and defensibly so, then we can see the intentional misuse of the brain sciences, its information, its capabilities to be able to affect our moral regard and our individual and community treatment of those who we define as norm or abnorm, functional or dysfunctional, and whatever labels of good or bad that we attach to that. And of course, if we just boldly go forward, what tends to happen here is there's a neglect of the necessary analysis, precaution, and preparation that can be used, and the leveraging of brain sciences in domains and dimensions that perhaps, although initially intended for good, generate considerable harm. The ethical, legal, and social issues and risks that arise from the brain sciences can be parsed into two principal categoricals, those that are focal to the technology. This is unknown science. We haven't been putting electrodes or devices or utilizing these cutting-edge drugs and other forms of chemicals and interventions and assessments for decades. And so we simply really don't know what the intermediate and long-term effects might be. But more than that, the intersection of unknowns. The brain is the great unknown. It is, in fact, in many ways, what the cognitive sciences David Chalmers refers to as the hard question or hard problem, not only of neuroscience, but perhaps of the human condition. We don't know how that great stuff of consciousness, of mind, of self arises from the gray stuff of those cells in our head. And arguably we could say, well, we won't know unless we go and use these technologies, but are we prepared for what we may find out and what we can do? What are the real capabilities and limitations? What is the validity and viability of uses of not only the information, but the actual skills, the technologies? What happens if the technology runs away from us, or what is sometimes referred to as incurs a Wechselblatt effect? In other words, we change nature in ways that have not been changed before as the engineers of our own evolution, only to create something, if you will, of a neurological golem that rises up, and suddenly when we pick our heads up from the proverbial workbench, we must ask ourselves, what have we done? Neuroscience doesn't occur in a vacuum, certainly not a social vacuum. None of science does. And as soon as we engage and understand that social milieu is important to what drives neuroscience and how those projects of neuroscience can be used in various social iterations, agendas, and iterations, then clearly then we see a whole host of potential questions. Is the brain mind an inviolable space? Should we not continue these levels of profound and ever more sophisticatedly detailed assessments? What about autonomy? Certainly, we can say that individuals' informed consent affords them the negative right of refusal that upholds their autonomy, but how informed can we be? And if, in fact, we're losing control of where the techniques, technologies, or even the data that is derived from them is held, the provenance, their custodianship, well, what are we consenting to? And will there be the necessary contingencies, as our group at the Pellegrino Center has argued for years, that consent demands at least explicit transparency of whether or not there will be continued research in clinical care? After all, if we're asking people to walk the wire of the neurosciences, we should tell them if there's a net underneath them or not. And that brings us down to issues of social awareness and understanding and what really does constitute treatment, protection, enhancement. And this gets back to the idea of the fact that neuroscience is now a global enterprise that entertains differing values, histories, norms, pluralities, and diversities of the 21st century world stage. Not only in terms of how we will use the brain sciences and what we will study and choose not to, and what those research methods may mean and what they actually articulate, but then ultimately what is produced and who will get those things and what will they be used for, what uses. And here we have to confront once again the idea of dual use. It's a balancing act. Our group over the past 15 years has been dedicated to trying to understand the possibility, if not plausibility, of utilizing a new approach to neuroethics. It combines a variety of different kits, a variety of different tools to create a more globally relevant, internationally capabilized neuroethics. It must appreciate cultural diversity on the global stage of those different groups, cultures, societies, and politics that are researching brain sciences and putting it to use, and how the uses of those brain science are then being, in fact, articulated on the contemporary 21st century environment. It also has to examine and identify and respect local needs and values. In other words, create community canvases from this palette of diverse ideologies and ethics that we must appreciate. But where it gets very, very difficult is where there may be differences, non-alignments, non-consensus of what those ideologies, values, and ethics may inform. And so what we're left with is something of the naturalistic question. What is and what ought to be in the brain sciences? And clearly what we understand of this is that science and technology, brain science and technology, and ethics provide tools, insights, and understandings that allow us to look into the brain. And in that way, perhaps neuroethics might be something neuroethical. By understanding the way we as humans engage the cognitive and emotional processes of what morality and ethics is, we might be able to gain better insight to how to use morality and ethics when regulating and guiding the brain sciences. But I think we have to appreciate two very important quotes. One from the historian of science, Bruno Latour, that science doesn't necessarily bring answers. It only deepens and makes ever more profound the questions. And Goethe, who said that science asks what, philosophy asks why, but ethics guides us how. And so the take-home message is, how will we in fact engage this new ethics? If brain science is boldly going, then we're going to need neuroethics that's brave. And I mean literally brave. That doesn't mean fearless. That means appreciating that there are things to be feared and engaging that terrain anyway, and doing it through a variety of processes that bring people together in more of a synthetic ethics. Neuroscience and technology is a multinational enterprise. This necessitates and acknowledges at least respect, if not complete sensitivity and appreciation of cultural similarities and dissimilarities. These non-identicalities in culture can create very distinct modes, means, and articulations of research, development, testing, and use of the brain sciences. And what this then does is opens the door for what may be research tourism or medical tourism. In other words, accessing different ecologies, different cultures, different political engagements so as to be able to get certain things done in research and or perhaps medical practice. Boutique brain science. What will we do with that? In one way, it can lead to very, very different balances of power scientifically, economically, intellectually, And this may create hegemonies, what the French philosopher Michel Foucault referred to as biopower and biopolitics. And as soon as we begin to talk about power and politics, we need to be aware of how the global stage will draw back its curtains and allow us to view the evolving play of neuroscience, and how will we both produce and direct that play. Ethics informs policy. Ethics must be about the enterprise, and ethics and policy must be temporally relevant and responsive. Like the science it seeks to guide, it must remain self-critical and self-revising. It should be dialectic and strive towards cooperation, and in some cases, some level of competition, what is sometimes referred to as coopetition, recognizing that competition is part of the human condition, but being cooperative in these enterprises may allow us some level of not only synthetic ethics, but syncretic ethics, where various beliefs are brought together in a way that allows consensus and domains of dissensus. What will the neuroethics be? Well, what can be done is certainly bold, without question. The questions are, what should be done? And how brave will we be in trying to get this done? Because the thing we don't want to do is to use the science and technology to iteratively unravel the Gordian knot of the brain-mind, only to open a can of worms with the way we regard and the way we use the things that we find and the things that we can do. And so very often in many of the lectures that I give about the brain sciences, I relate back to a personal story, one of my dad, and I'll do so again unapologetically here. My dad was an engineer. He was a nautical engineer. And he liked to fiddle with things, and he liked to use tools. And one of the things he taught me to do, a sort of father and son activity when I was a kid, was to build things and repair things. And it's something I still like to do in my spare time. My dad was a good teacher. He used to bring home a new tool a month. The first Tuesday would be New Tool Tuesday. So I'd get to learn an awful lot about tools, and we'd spend the next month doing that. Well, I remember I was about 10 years old, and we'd been doing this gig for about 4 years. So I had a pretty good toolkit under my proverbial belt. And Dad comes home with a new tool one Tuesday, and I was so excited. I remember I grabbed it, and I was going to go running down to our workbench to work on our project. My father put his hand on my shoulder, and he said, "Jim, slow down. Measure twice, cut once. Because sometimes you can't take back what you do with your tools." Wow, Dad. What a great adage for the brain sciences and for neuroethics. We need to measure twice before we make certain cuts of what we allow ourselves to do or not to do in the brain sciences. And we certainly need to measure twice the way we develop a new neuroethics that's going to be ever more globally capable. It's a challenge and it's an opportunity. It's an exciting field and an exciting time. And I thank all of you for spending this time with me. If you want some more information about what my group is doing over the past 10 years and where we're headed, I provide this for you here. And if you wish to get in touch with me, please feel free. I welcome your comments. I welcome your contact. And you can reach me at james.giordano@georgetown.edu. Thank you for your time.